Hello and welcome to Airlines 101 with Laura. Today we are going to look at how to do weight and balance calculations for removing a piece of equipment from an aircraft and then making sure that the aircraft will remain within its allowable center of gravity envelope for the most forward and the most aft adverse loading conditions. So I've given a problem here on the screen. I'm given some aircraft weights, some locations of various things within the aircraft, and we have a certain amount of weight that we're going to remove. And in this case, we are going to remove 245 pounds of equipment from the aircraft. So let's get started and look at that equipment removal process. First off, we have our current aircraft's empty weight, which we have weighed the airplane, and we have the current aircraft center of gravity, which has been calculated before. And we're removing 245 pounds of equipment in this case. It's located at 275 inches. And I do want to say this aircraft here shown, it's just a representative aircraft. None of these numbers are all associated with this aircraft type in particular. They're just theoretical numbers. So just for example purposes. So our old center of gravity is located at 145.6 inches. So kind of centrally located to our airplane. We have a datum, that's our reference point. I'm going to assume in this example that the datum is located at the tip of the aircraft's propeller spinner. And we're removing 245 pounds at 275 inches aft of that datum. So it's a fairly simple calculation to remove that. Here's an equipment change form that we use here at LeTourneau University, and just give you an example of how to fill out that form. First, we're going to input our original aircraft configuration information. We have the aircraft's empty weight, the aircraft's original center of gravity, and the moment, which we can calculate by just multiplying our weight by our arm, and that gives us the moment. So if we do that math, 23,574.5 pounds times 145.6 inches, we get a new moment, and you see that number displayed there. But now we have to remove that equipment. So we're removing some equipment that is at 245 pounds. Notice I've put a negative number on here because we are removing it. We have its location, 275 inches aft of our datum. So we use that same formula. The weight, 245, times the arm, 275. We get a moment, a negative number, 67,375. It's good that it's negative. We're removing that weight. So it's also going to be a negative moment. Now I just total up the items that we're going to remove. We could use this form for more than one piece of equipment to be removed from the aircraft. But in this example, we just have one item being removed. Now our final calculation section of the form. I'm just going to transfer from the top of the form our weight from before, our arm from before, and our moment from before from our empty aircraft. And then we're going to move down our removal weights. So we just have our negative 245, our arm of that weight being removed, and the moment. And then all I need to do is add up my weight column. And so I've got a new number, a new empty weight of 23,329.5 pounds. And then I'm going to do the same, add up my moments. And with adding up those moments, so I have a negative moment because we're removing some weight, that piece of equipment. Add it to our previous aircraft moment, and you see our new moment. It is smaller. It's good because we removed weight. And then I do my calculation of our total moment divided by our total weight, and that gets us our center of gravity. So doing that math, we just divide our moment, and I can even pull up my calculator here. So here's our moment, 3365072. Divided by 23,329.5, and I get a new moment of 144.24 inches. And we can enter that into our form as well. So 144.24 inches is our new center of gravity once we removed that weight. Okay, so that's how we do the equipment removal problem. Now, once we have removed a piece of equipment, we want to see if that has changed our loading of the aircraft and make sure that we aren't going to inadvertently load the aircraft outside of its normal operating envelope, our safe operating envelope. And so to do that, we are going to do a theoretical calculation of our forward adverse loading and our aft adverse loading. So for the most forward loading, we're going to start with that. Here's some information. I've moved over our new aircraft empty weight, our new center of gravity, we just calculated it, and some other information, our fuel capacity, the fact that our theoretical airplane, I know this is a larger airplane than a 4-seat airplane on the picture, but theoretical, so our airplane in our example only has 2 forward and 2 rear seats. Maybe we have a lot of room for cargo in the middle of it or something, I'm not sure. So our acceptable center of gravity range is given to us with that aircraft model. And in this theoretical example, it goes from 130 inches to 168 inches aft of our datum. So that I'm going to just assume it goes from about this location, 130 inches, to this aft location of 168 inches. So that's our center of gravity range in which the aircraft's balanced and everything is safe for our normal operations. But what we want to do with this calculation is figure out, is it possible using our things that we can put in the airplane, is it possible to go load the airplane outside of that range of center of gravities? And we don't want that to be a possibility, so that's why we're checking that and see if that is a possibility. So first we have to have a pilot on board, okay? A minimum thing required for flight is 1 pilot. So here's a pilot. I have labeled the pilot wings as 184 pounds. That is just a general theoretical number. Again, we have to use some assumed weight, and the FAA has certain assumed weights, which they change over time. Other countries have other assumed weights. For the purposes of this adverse loading calculation, we use 184 pounds for each person. So we have to have a pilot on board. The other thing that we have to have on board the aircraft for flight is what's called minimum fuel. And it's an extremely easy formula to calculate the minimum fuel weight. I've shown it up there. It is called METO divided by 2. That's our formula for the minimum amount of fuel in weight that we have to have on the aircraft for these adverse loading calculations, these theoretical loading calculations. So we need an aircraft, a 1 pilot, our minimum fuel. That constitutes items needed to fly this aircraft. How do we do that METO divided by 2 though? Let's look at that a little more detail. So that METO divided by 2 gives us our pounds of fuel that is required for minimum fuel for adverse loading theoretical calculations. In this example, we said that the METO for the aircraft was 400 horsepower. That was given to us at the beginning of our problem. So let me go back and show you that. So here is our engine horsepower that is shown to us, and it is 400 horsepower. That is our METO horsepower. Okay, so going back over here to my example, our METO is 400 horsepower. So by my formula, all I have to do is divide 400 by 2, and that tells me it's 200 pounds. Okay, notice this formula gives us pounds. So it's very simple. We take the horsepower, we divide it by 2, and that gives us our minimum fuel for theoretical adverse loading in pounds. Okay, recall that it is pounds, extremely important to note. So back to where we're adding these items in the aircraft. First of all, we have our 184-pound pilot. The pilot is located at 125 inches. Notice I've shown on the diagram, it's slightly forward of 130 inches. and that's fine for now. We also have 200 pounds minimum fuel, and it is located at 29 inches. So I know there probably is not a fuel tank at that point in the aircraft, but it's a theoretical aircraft. It's example purposes only. These items here, our aircraft, our one pilot, and our minimum fuel, these are the minimum items needed for flight. So let's take a look at the form where we're going to enter that information. And then we also want to think about the fact that it's a forward loading problem. That means anything that is forward of my acceptable center of gravity range, which is 130 inches, that's the beginning of my 130 inches, that's the beginning of my range. And if you look at my diagram here, I have drawn a rectangle, so 130 inches is at this location. Anything that is forward of this location, we are going to maximize that weight. We want to maximize that weight to see if it's possible to load the aircraft where it goes out the forward center of gravity. There are 2 forward seats, and our fuel capacity is 125 gallons of fuel. So at this point, I make sure I've got my items needed, plus maximum weight of things forward of that allowable center of gravity range. So in that shaded box where it says maximize weight, those are the things that we're going to maximize. So that means if I have an extra seat up front, I'm going to add a second person sitting up there next to the pilot, because you can see that 125 inches falls in our shaded area. It's forward of 130 inches. And assuming weights again for these calculations, we're just theoretical. The person is going to weigh 184 pounds. Now, the other thing that we have to think about is, where's our fuel tank? Our fuel tank, we can see, it's well forward of 130 inches. In fact, it's located at 29 inches. So it's very far forward. And so then we have to put maximum fuel in that fuel tank also when we're doing this theoretical forward loading calculation. So let's do that. We're going to add 550 pounds of fuel at 29 inches at 29 inches location. Now you might be saying, how did we get 550 pounds of fuel? I will show you. So we had we had our max takeoff power of 400 horsepower. We did our divided by 2 to get 200 pounds. And then I'm looking at our maximum fuel capacity is 125 gallons. With a 125 gallon tank at 6 pounds a gallon, because that's what aviation gas weighs, 100 low lead, and that's the example we're using here. We're just going to assume it's a reciprocating engine-powered aircraft that runs on aviation fuel. So 125 gallons times 6 pounds per gallon, and I get 750 pounds of fuel that can fit in my 125 gallon tank. However, remember, we already have 200 pounds loaded because it's part of our minimum fuel. So I'm going to then subtract 200 pounds that we've already loaded as part of our minimum fuel, and that gets me 550 pounds. So 750 pounds max fuel capacity, subtract our 200 pounds minimum fuel, and we get 550 pounds of fuel that we add for that forward loading theoretical calculation at 29 inches. Okay, so here's the picture of what you see going on. Let's go ahead and complete our form. So again, we have a different form. This is called adverse loading calculations form. I'm going to show you how we're going to fill out that form. Starting with the top section, that's where we're going to list the things that are required for flight. First, we have the aircraft. There's our aircraft. We removed that equipment. There's our new weight. There's our new center of gravity. We list that under arm, and there's our moment. Now, what was our minimum fuel? Our minimum fuel, we said, was 200 pounds. That was that 400 horsepower METO divided by 2. We get 200 pounds. and that was located at 29 inches. Next, we have our pilot. Oh, I calculated the moment as well. So we have our same formula, weight times arm equals moment. Now, also we have to notice that we weighed the aircraft with oil on board. So we're going to skip the line that says oil if not included in our empty weight, because in this example, we did include it in our empty weight. Now we have our pilot. The one pilot weighs 184 pounds. The front seats are located at 125 inches. So doing that again, weight times arm equals moment, and we get 23,000. Now I'm just going to add up my weights, add up my moments. Feel free to pause the video if you want to do that yourself. And then we use our formula, moment divided by weight, and we get our center of gravity. So that's our center of gravity right now with our minimum items required for flight. One pilot and minimum fuel plus the aircraft. But now, we said we have to calculate most adverse. So let's go ahead and fill out the rest of the form for the forward adverse loading. I move my items needed from the top of the form, move them down here to the top of our items needed, is what we call these. We have additional fuel, right? And we said that was going to be 550 pounds because we have a 750 pound capacity. It's located at 29 inches. That's well forward of our CG allowable limit, which was 130 inches. So it's forward of that location. We do our weight times our arm. We get our moment for that. We get front seat, one passenger. Again, they're 184 pounds, our theoretical weight. That front seat is located as same as the pilot's seat, 125 inches. And then I can calculate both moments. Weight times arm equals our moments. And you can pause the video if you like and add all these items up. So I'm going to add them up. I get my total weight, 24,447.5 pounds. Add up my total moments, and there's our number. And then we just divide that out again. So we'll pull up our calculator. 343, 28, 23 divided by 2447. Lost a 4 in there. And we get 140.4. Good. So we can write that on my form. Now, we also want to check to be sure that that's within our allowable center of gravity range. And it is, because our allowable center of gravity range falls from 130 inches to 168 inches. So it is within our allowable range. Okay, now that was our forward loading calculation. Let's look at the most aft condition. Stay with me. It's not that much more additional work. We just have to think that this time we want to maximize everything that is aft. So aft of our rearward limit of 168 inches. So look again at our airplane example. Got my minimum fuel on board. I got my pilot on board. 168 inches is our aft limit. That's where we're going to maximize our weight. So in this region with that shaded rectangle you see there. So what items are in that area? Well, I've updated my list. We have those 2 rear seats. We have also a baggage compartment that's 300 pounds capacity. And we have to look at where these things are located before we determine, are we going to maximize them? If they fall into this shaded rectangle, we got to maximize them. So the rear seats, if we go back to our original example, the rear seats are located at 175 inches. We see those here, and our baggage is at 225 inches location. So going back to our adverse calculation here for aft, the rear seats at 175 inches, we're going to maximize those because we have our items needed, pilot, fuel, airplane, plus the maximum weight of anything aft of our allowable CG range. So our CG range stops at 168 inches. The baggage, let's look at that first. 225 inches is well aft of 168 inches. It definitely falls in our shaded rectangle where we're going to maximize that weight. and we have 300 pounds capacity, so we need to maximize that and put 300 pounds in for our theoretical calculation. What about the rear seats? So the rear seats we saw, those are at 175 inches. And in this example, there's 2 rear seats. So 2 people we have, and our 2 people each weigh our assumed 184 pounds. That gives us 368 pounds in our rear seats. And we do want to maximize them because they are at 175 inches, which is well aft of the 168-inch limit. It's by 7 inches aft, okay? So these 2 areas, we are going to maximize those weights. Let's go back to our form. So the items needed for flight, nothing has changed up there. Nothing at all. We still have our empty aircraft. We still have our fuel. We still have our pilot. So that's fine. No problem with there. I'm going to transfer those items down to our items needed. Okay, so we take those things down. Now we're going to list our maximum loaded aft items. Start with our baggage. So we put our baggage in here. Remember, it was 300 pounds and it's located at 225 inches arm. And then we have our rear seats. So we've got our 2 people in the 2 rear seats. The 2 people weigh 368. We have the seats. Oh, that's a mistake. That should say, I can fix it. That should be at 175. Oops, okay. And the moment for those works out, I believe the math is correct on that, to 64,400, but let's do the math. 368 times 175, 64,400. Yeah. Okay, so we're going to add up our total weights. There we have our total. We're going to add up our total moments. We're going to use our moment divided by weight to get our new center of gravity. And I get 144.6 inches. So we got to stop and check, is that within our allowable center of gravity range? And I can see that it is, because our allowable center of gravity range is 130 inches to 168 inches. So now those of you who are watching and you're pilots, you might think, why would I ever do all this theoretical loading? You probably wouldn't, okay? What is going to be done though by your maintenance technician, once we add or remove something, we've got to do a theoretical calculation to make sure that you're kept safe in your flying. If we do the calculation and we have somehow, it is possible to go too far forward of our CG limit in a certain loading configuration or too far aft in a certain loading configuration, then the maintenance technician is going to install a placard so that the pilot has warning that the aircraft can be loaded outside the center of gravity envelope with these theoretical calculations. Thanks for watching. I hope you learned something, and I hope it helps you understand this theoretical loading for max forward and max aft loading of an aircraft.